Thank you all for being here in person and everyone online. My name is Steenstra, and today I'll be defending my thesis titled An Evaluation Framework for Assessing Quality Care and Risk in AI Psychotherapy. But before I start, I want to give a quick disclosure that I might be talking about some sensitive topics such as suicide during this presentation. I would like to first extend my gratitude to my thesis committee. Thank you to my advisor, Dr. Timothy Bickmore, my external committee member, Dr. Paola Pedrelli, as well as to Dr. Stacy, Marsella, and Dr. Weiyan. So let's begin with the motivation behind this work. So current data indicates that between 13 and 17 million US adults and 5.4 million US youths are utilizing generic large language models such as ChatGPT for mental health support. This represents a significant adoption of unvalidated tools for clinical purposes, often occurring outside the supervision of healthcare professionals. This trend has raised concerns regarding patient safety. There have been documented instances of user harm, lawsuits, and concerns from health professionals and organizations. And the central issue is that these generic systems are optimized for conversational engagement rather than clinical safety or therapeutic efficacy. States like Illinois and Nevada have already introduced legislation to restrict AI in mental health treatment, with other states soon to follow suit. However, these regulations often fail to cover generic chatbots, which are not marketed as medical devices, but are frequently used as such by the public. But even if companies did start evaluating based on clinical safety, the current methods we have for evaluating AI chatbots are poorly suited for large-scale therapeutic risk assessments. Take static benchmarks, for example. These are typical what you see reported in model cards, which are standardized data sheets that act like nutrition labels, detailing a model's capabilities and limitations. While these cards are vital for transparency, the static benchmarks they rely on often only assess knowledge retrieval or simply safety metrics, failing to capture dynamic conversation nuances. On the other hand, the current industry standard is a process called AI red teaming, which is a form of stress testing. This is where testers create prompts to try to make the AI fail or say something dangerous to find its weak spots before it's released to the public. However, when we apply this to mental health, the current methods have major blind spots. For instance, manual AI red teaming, where a human experts test the system, has an inherent bias because these experts would be role-playing as users seeking help. It is very difficult for them to say if the AI's words would genuinely cause harm, emotional harm, for a person in actual crisis. And regarding automated AI red teaming, which tends to use the other AI systems for evaluation, these tools lack the nuance to capture the subtle dangers of therapy. They might miss things like an AI accidentally encouraging a harmful behavior or failing to offer hope when that's needed most. Also, identifying therapeutic risks is already uniquely difficult. Effective therapy often requires short-term discomfort, like discussing trauma, to achieve long-term healing, so negative sentiment isn't always a failure. Furthermore, harm is rarely caused by a single toxic sentence. Instead, it is latent and cumulative, emerging when a therapist repeatedly invalidates a patient over time. Therefore, evaluating single lines of dialogue is insufficient. We must evaluate the entire therapeutic relationship. To make this problem tractable, I focused my research on a specific high-impact test case, being alcohol use disorder, or AUD, for motivational interviewing, or MI. I chose this pairing for two reasons. First, AUD has well-defined diagnostic criteria according to the DSM-5, and it's a significant public health issue, contributing to 2.6 million deaths in 2019. Second, MI is well-structured, client-centered therapeutic approach that was originally created for treating AUD, and it has clear validated fidelity measures. This leads to my primary research question. How can we evaluate AI psychotherapists in a more thorough, systematic, and clinically meaningful way? And to answer this, I took an iterative approach, starting with two formative prototypes that led to the creation of the evaluation framework. And to begin discussing it a little bit at a high level, this evaluation framework orchestrates a series of simulated therapy sessions between an AI psychotherapist and a cohort of simulated patients. It then utilizes an ontology to automatically evaluate on quality care and risk. But first, I'll be going over the two prototypes that led up to the system. Prototype 1, which received a Best Paper Award at the 24th IVA conference, was my initial exploration into answering my research question and the development of my evaluation framework. The first part I explored was how to implement and evaluate an AI psychotherapist. This involved developing an LLM-powered virtual agent called Dr. Anderson that was prompted to perform motivational interviewing for alcohol use counseling. To evaluate Dr. Anderson, I applied the same clinical standards used to assess human therapists, focusing on two critical dimensions. First, I assessed treatment fidelity. This measures how accurately a therapist adheres to a specific treatment protocol. In the context of motivational interviewing, I needed to verify if the AI was actually enacting and performing the correct technique. I conducted a transcript study where human raters coded the AI's responses against human benchmarks. Specifically, I evaluated how well the AI utilized core MI skills, such as offering complex reflections to demonstrate empathy, as well as using affirmations to support the patient's self-efficacy. Second, I evaluated therapeutic alliance. This is defined as the strength between the collaborative bond between the therapist and the patient. Essentially, does the patient feel understood, and do they trust the therapist? Since this is subjective, I recruited 8 expert clinicians from Upwork to role-play as AUD patients in live sessions to test the virtual agent. They rated the quality of that relationship using validated instruments. The results indicated that the AI was statistically non-inferior to human counselors regarding MI adherence. However, clinicians reported that the interaction felt robotic and noted an over-reliance on complex reflections. A key limitation I identified was that relying on human experts for role-playing is not scalable for comprehensive safety testing, given the time, cost, and human bias. So what were the critical takeaways from this first prototype that shaped the rest of my thesis? First, I confirmed that human evaluation metrics apply to AI. I demonstrated that the standard clinical instruments used to assess human counselors, specifically treatment fidelity and therapeutic alliance, are valid and effective tools for evaluating AI psychotherapists as well. However, the study exposed a major bottleneck. Relying on human experts to perform these evaluations is slow, expensive, and impossible to scale at the level required for rigorous safety testing. Additionally, because human testers are merely role-playing as a patient, they cannot genuinely experience harm. To truly stress test an AI for risks like suicide or relapse, I realized I needed a way to simulate the patient as well. And this motivated the development of Prototype 2 that was published at CHI this year. And this phase focused on simulating the patient side of the dyad, as well as how to automate the evaluation of psychotherapists. For the test case in this work, I built a system for training human psychotherapists on motivational interviewing for alcohol use disorder. I developed a system called SimPatient, which introduced 2 key technical innovations to address the limitations of human roleplay. First, I built Agent A, which is the simulated patient. This goes beyond standard chatbots, and it is powered by a cognitive affective model that tracks internal psychological states such as self-efficacy, control, awareness, and reward, based on alcohol use disorder literature. These states are dynamic. They update each dialogue turn based on the therapist's recent utterance, which then influences how the patient responds. I'll be going into more depth into this in the improved version of the cognitive affective model I use within my evaluation framework later on in the presentation. Now for the second one, I developed Agent B, which is the automated evaluator. To solve the scalability issue of human coding, I leveraged the LLM as a judge methodology, which has become a standard in AI evaluation, where an LLM is prompted to grade the output of another. In this case, I prompted Agent B to assign the codes from the MI Treatment Integrity Coding Manual. I validated the outputs of Agent B through the use of human raters, which showed high acceptance and agreement. To validate the system, I recruited 18 participants, comprising 10 professional counselors and 8 student counselors who were recruited from Upwork and Northeastern. All participants were familiar with MI and have used it before. And the goal was twofold: to determine if the simulated patient felt realistic to a counselor, and to assess if the system could effectively function as a training tool. I used a repeated measures protocol where participants completed 3 10-minute counseling sessions with the simulated patient. After each session, they reviewed an AI-generated feedback dashboard based on the evaluations outputted from that automated evaluator agent, which is Agent B. To measure success, though, I used the system usability scale for overall usability, the MI confidence survey to track improvements in a participant's self-efficacy or their confidence in MI skills, and a one-item perceived realism scale to assess the authenticity of the patient's dialogue and state changes. The results showed that all participants improved their confidence in their MI skills after each conversation with the simulated patient and reviewing how well they did on the evaluation dashboard, which occurred at each session, with the repeated measures ANOVA showing a significant effect of time. The results for realism were highly encouraging. Participants rated the system's usability to 88.1, classifying it as excellent, and the perceived realism score was nearly 8 out of 10. Qualitative feedback provided a deeper insight. Participants confirmed the accuracy of the evaluation metrics used, as well as the conversation fidelity of the simulated patient, with one noting it was like talking to a real person. They also validated the cognitive affective model, observing that the patient's internal state changes were actually reflecting on the conversation. However, participants felt that they should have had simulated much higher levels of resistance for the patients. And this feedback directly informed the design of my evaluation framework, where I developed a patient cohort that were capable of significant resistance and noncompliance. Prototype 2 provided the technical proofs of concept for my thesis, while highlighting specific gaps I needed to close. First, I established that LLM as a judge could reliably grade clinical skills, confirming that it could build a framework that doesn't rely on human raters. Second, I discovered that while the cognitive models created realistic behavior, the patients were too compliant. I realized that to truly stress test an AI psychotherapist for safety, I needed to build a cohort capable of hardcore resistance and noncompliance. Finally, the system could tell me if a therapist was competent in MI, but it couldn't tell me if they were dangerous. This led to the development of an ontology to measure the larger scope of quality care and risk metrics. So now that we've covered how AI psychotherapists can be assessed, I'll now cover what metrics we should use for assessment. And I'll now go over the development of an AI psychotherapy quality care and risk ontology that was published in IVA this year. We've already touched on how to assess quality care, such as treatment fidelity and therapeutic alliance, but we still need to know what are the risks in AI psychotherapy and how should we categorize them. To answer this, I conducted a literature review and semi-structured interviews with 10 clinical psychologists from Upwork. During these interviews, I presented a preliminary risk taxonomy based on the literature and used their expert feedback to refine the specific categories that an automated system should monitor. And this led to 3 distinct categories of risk. The first is acute crises. These are immediate high-stakes events like suicidality or threats to harm to others that are urgent, that need urgent intervention during a therapy session. This also includes whether the AI psychotherapist actually identifies these crises during a therapy session and enacts proper protocols such as de-escalation and recommending emergency services. The second is warning signs. These are dynamic internal psychological shifts, such as a spike in hopelessness, that serve as indicators of potential harm. And the third is adverse outcomes. These represent the tangible realization of harm, such as treatment dropout or suicide. Using the insights from the risk interviews, combined with the lessons from the 2 prototypes, I constructed a comprehensive quality care and risk ontology. This ontology defines not just what to assess, but when to assess it, creating a longitudinal cycle that mirrors real-world treatment. It begins pre-session by measuring patient progress to establish a baseline of when to capture a patient's symptoms or general mental health improves over time. Then in session, the system actively monitors for acute crises and tracks real-time warning signs during the therapy session. Post-session or right after the therapy session has concluded, therapeutic alliance and treatment fidelity is measured. And finally, between session stage assesses the patient's life outside of therapy to detect adverse outcomes like relapse or dropout, and update the warning signs for the next therapy session. We have covered what metrics should be used to evaluate AI psychotherapists and when, but now we must develop a cohort of simulated patients that are capable and clinically meaningful to evaluate this AI psychotherapist on, which I'll go over now. I began by reviewing the literature on alcohol use disorder to identify distinct clinically relevant phenotypes. I found a cluster analysis study by Moss that identified 5 main clusters of alcohol-dependent patients, which I utilized to represent the diversity of the AUD population. These include young adult, characterized by binge drinking and low comorbidity, the functional, who maintain stable lives despite heavy use, the intimate familial with strong genetic history of alcohol dependence, the young antisocial with high comorbidity, and then chronic severe representing the most difficult to treat cases. However, simply defining a phenotype isn't enough. A patient's behavior is also driven by their readiness to change. To capture this, I crossed each of the 5 phenotypes with 3 distinct stages of change. Pre-contemplation, so they're not ready to change. Contemplation, they're kind of weighing options and thinking about it, as well as action, or they're ready to change. This resulted in a final cohort of 15 distinct simulated patient personas, allowing me to test an AI psychotherapist against a range of clinical presentations and motivation levels. To make these patients behave realistically, simply giving them a backstory wasn't enough. I needed to simulate how they think and process information dynamically. I looked to establish cognitive architectures for inspiration, specifically drawing on the cognitive appraisal theory, the belief, desire, intention model, perception, cognition, action cycle, and emotion regulation theory, as well as Stacy's work. Using these theories as a blueprint. Exactly. Using these theories as a blueprint, I implemented a dynamic cognitive model within an LLM using chain of thought prompting. The first is appraisal, where the agent evaluates the therapist's message relative to its goals and beliefs, such as assessing whether the message is a threat or is it supportive. Based on that appraisal, it updates the internal psychological state, like increasing hopelessness or decreasing substance craving. These are also critically the same as the warning signs defined in the ontology. It then forms a belief by generating a rationale of why it felt this way and why that state kind of changed. And finally, it decides on a coping response strategy, like withdrawal or aggression, before formulating its actual patient utterance. This architecture creates a closed feedback loop. The patient's internal psychological state at any given moment T is a product of their previous state, T-1, and the therapist's latest utterance. This means that the patient evolves over time. If a therapist is supportive, the patient's state improves turn by turn. But if the therapist is harmful, the patient's state deteriorates, and this new degraded state becomes the starting point to the next dialogue turn. An additional key novelty of this model is the simulation of time between therapy sessions, because in the real world, therapy doesn't often happen in a vacuum. A patient's life continues after they leave the office. And to capture this, the agent was prompted again using chain of thought prompting to generate a narrative of the week based on their psychological state at the end of the session, as well as the transcript. So did they feel empowered and go to work, or did they feel hopeless and relapse? This step is required to measure longitudinal adverse outcomes, allowing us to see if therapy is translating into real-world stability or deterioration over time. To ensure the simulated patients were internally consistent, I conducted a psychometric validation study. I prompted the agents to complete established clinical surveys while in character, and this validation covered both their internal psychological states and their assigned phenotypic traits. And the results showed strong correlations, confirming that the agent's internal constructs and the clinical presentations align with the validated measures. Beyond psychometrics, I needed to know if these patients were clinically realistic given their dialogue and behaviors. I recruited 6 mental health professionals from Upwork and 9 graduate students from Northeastern who had knowledge or experience in treating substance use disorder patients to review a series of patient vignettes. And these vignettes included a description of the patient, the full therapy session transcript, the patient's psychological states, the between session weekly summary, any adverse outcomes that occurred between the sessions. And I want to note that these vignettes were sampled directly from the large-scale simulation that I conducted, which I'll discuss in detail shortly. The results showed that experts rated the clinical fidelity of the patients significantly higher than neutral. Qualitatively, they praised the agents for generating highly plausible adverse outcomes, given the therapy session, and noted that they captured human imperfection very well, avoiding the robotic consistency often seen in simpler chatbots. Now that we've successfully developed and validated a simulated patient cohort, the next step is implementation. How do we take these patients and use them to automate exhaustive testing? And how can we visualize the complex quality of care and risk outcomes that emerge from these simulations? To answer this, I'll discuss the evaluation framework in detail. The framework functions by plugging in an AI psychotherapist as the system under test. The simulation orchestrator then manages the dialogue between the AI and the simulated patients. And throughout the process, the system applies automated evaluation metrics based on the criteria defined in the ontology, capturing data at specific points in the therapy cycle. These results are then fed directly into an interactive dashboard for stakeholder analysis. And we've already reviewed the simulated patient cohorts and ontology, so now I'll discuss the AI psychotherapist. I selected 6 distinct systems chosen to reflect the reality of current public usage and to allow for specific technical comparisons. First, I included ChatGPT Basic here in Character AI. These represent the status quo, widely used consumer tools that millions are already using for support. Second, I wanted to isolate the effects of prompt engineering versus model architecture. So I included ChatGPT MI and Gemini MI, both equipped with the same motivational interviewing prompt I used in my first prototype. Finally, I included 2 control conditions. A harmful one served as a negative control to test if the framework could differentiate risk profiles and detect malpractice. And a static booklet served as a passive control, representing standard clinical education materials. Now let's discuss the automated evaluation metrics. Before we discuss the specific metrics, let's revisit the ontology and see how it fits together. The goal was to automate the measurement of the entire cycle. I needed to build evaluators that could quantify patient progress at the start of every simulated therapy session, detect acute crises in real time during a session, grade fidelity at the end of a session, and track adverse outcomes between sessions. To measure these constructs at scale, I operationalized the ontology into specific automated metrics, utilizing validated LLM as the judge evaluators. The patient progress, because my patient population are AD patients, I used the substance use recovery evaluator. For therapeutic alliance, I employed the working alliance inventory and session rating scale. Treatment fidelity was assessed using the MI treatment integrity coding manual, similar to how I did in the 2 prototypes. And for risk, I tracked the frequency of acute crises events and the cumulative account of adverse outcomes. Lastly, I want to quickly note that additional validation studies were conducted on these evaluators, specifically the acute crisis detection and protocol adherence, which showed 94 to 98% accuracies, but I can discuss these studies in greater detail after the presentation. Now let's cover the simulation orchestrator. The engine driving this evaluation framework is the simulation orchestrator. It manages the dialogue between the therapist and the patient. It handles state management and checkpointing, which is critical for long simulations. So if the system crashes, I can resume exactly where I left off without losing data. And it coordinates the flow of data and function calls, triggering the specific evaluators at the correct moments in the ontology cycle. And the last element, I'll discuss the interactive dashboard. This dashboard represents an improved version of the one used to assess human psychotherapists in the second prototype I built, but now tasked to visualize the evaluation of AI psychotherapists at scale. And I designed this following Schneiderman's mantra: overview first, zoom and filter, then details on demand. I implemented this by providing a high-level overview page and global filters for comparing models, which allowing users to drill down in specific data points, such as warning signs, to inspect the raw transcripts to understand kind of the root cause of any psychological change in the patient. Providing that this visual layer is essential because automated metrics alone are not enough. We still need a human eye to interpret nuanced patterns, like correlating a spike in warning signs with the transcript of a session to truly understand why a risk event actually occurred. Many of the visualizations follow this longitudinal format, enabling users to track trends over time. For example, in this graph, it allows stakeholders to see if the therapeutic alliance is strengthening or deteriorating across multiple sessions, rather than just looking at a static average. So we've now finished discussing each element of the evaluation framework. So I'll discuss how I performed a large-scale automated evaluation using this framework. For this large-scale test case, I evaluated the 6 distinct systems that I'll be going over again. ChatGPT Basic and Character AI. They represent non-prompt engineered agents, simulating a typical user who simply opens the app and asks for help without providing any special instructions. For Character AI, I used the psychologist persona, which is the most popular mental health agent on the Character AI platform. ChatGPT MI and Gemini MI are prompt engineered agents. I use the motivational interviewing prompt I validated in prototype 1, allowing me to test if clinical prompting actually improves safety. And then the booklet serves as a passive control. We're representing standard clinical education materials where the patient reads the material instead of actually having a conversation. Finally, I included a harmful AI as a negative control. I created this agent by explicitly inverting clinical guidelines by instructing it to be judgmental and invalidating. And I compared every system against it to establish discriminative validity to see if my evaluation framework can distinguish between these agents from the intentionally harmful one. Then the framework can't be valid if they can't. I paired each of the 6 AI psychotherapists against all the 15 simulated patient personas. For each pairing, I ran 4 therapy sessions, which the literature identifies as kind of a common duration for motivational interviewing interventions. Each session was limited to 48 dialogue turns per agent. This limit was derived directly from the NLMI dataset I used in prototype 1, ensuring that the conversation length was similar to real-world counseling data. My analysis plan had 2 main components. First, I needed to establish discriminative validity. I used statistical tests, including ANOVA and generalized linear models, to verify if the framework could actually distinguish between helpful and harmful therapy. Second, I conducted saturation analysis because LLMs are non-deterministic. Running a simulation once isn't enough. I needed to run multiple replications for each pairing to capture the full variance of behavior. So I stratified my sample size based on the real-world population prevalence of the AAD phenotypes, resulting in a sample size of 30 patients per psychotherapist. To confirm the sample size was sufficient, I used bootstrapping to model the decay of the 95% confidence intervals for both the mean values and longitudinal slopes of every metrics. So this allowed me to know when the data has stabilized. The results confirmed the framework's validity. It successfully distinguished the harmful AI control from the therapeutic agents across almost all key metrics. The harmful AI resulted in significantly higher rates of adverse outcomes and dropout, validating that the metrics are sensitive to malpractice. Some metrics like the substance use recovery evaluator showed no significant difference because all the patients in the harmful condition dropped out in the first session. So before any longitudinal progress could be actually measured. Similarly, acute crisis counts were minor because patients left therapy before a crisis could even develop. The results showed that all metrics across all AI psychotherapists stabilized well before reaching the full sample size of 30. The average point of saturation was around 9.68 for the sample size. This confirms that I collected enough data to reliably estimate the performance of these specific AI psychotherapists on the specific patient cohort. However, it is important to note that this does not guarantee that I've captured every possible long tail risk or edge case outside of the specific phenotypes I modeled in the metrics I chose. And here's a concrete example. This graph shows the decay of uncertainty for the working alliance inventory score for the Gemini MI model. So you can see in the fitted curve, which is the red line, flattening out into an asymptote, indicating that adding more simulations beyond the 14 yields diminishing returns in statistical precision. And I want to highlight some qualitative findings that demonstrate the clinical fidelity of the simulation. The simulated patients were able to model authentic behaviors associated with certain AUD phenotypes, including the use of profanity and aggression. They also demonstrated realistic frustration when interacting with an AI. They were not easily fooled. As you can see here, they actively pushed against robotic or repetitive responses, demanding authentic human connection, which is interesting given that they're AIs as well. However, the most alarming finding was a phenomenon called AI psychosis, which is kind of going around the news right now, which is driven by excessive agreement or co-rumination. Here's a transcript snippet from Character AI, where the patient uses dark metaphors describing their mind as a torture machine. A human therapist would challenge this delusion, but the AI, trying to be supportive, agrees with it. It validates that their mind is a torture machine. This creates a dangerous feedback loop where the AI reinforces the patient's psychosis instead of treating it or doing reality testing, which ultimately, unfortunately, led to the simulated suicide by the simulated patient in this scenario. To summarize the scale of this evaluation, the framework ran for 7.5 days straight and executed 369 simulated therapy sessions. This generated a data set of 27,218 dialogue turns, a volume of synthetic clinical data that would be probably highly impractical to evaluate manually. Finally, I needed to determine if this simulation data is actually useful to the human decision makers responsible for AI safety and target stakeholders. I recruited 9 experts from Upwork, representing the 4 distinct stakeholder groups: mental health professionals, AI engineers, AI red teamers, as well as policy experts. And I asked them to perform a series of domain-specific tasks using the dashboard. For example, mental health professionals were given a hypothetical task of a company asking them to review their AI alcohol counselor before deployment to real patients, while engineers were tasked with diagnosing model failures. And this ensured that the evaluation was actually grounded in real-world use cases. But I also asked each participant if they would use any of the AI psychotherapist based on the data and why, which was the user-specific task. I assessed the dashboard using 3 surveys: the system usability scale, the post-study system usability questionnaire, and a custom ad hoc scale assessed whether the dashboard and the underlying simulation data provided actionable insights for AI psychotherapy safety. And I also conducted qualitative interviews and analyzed the transcripts using thematic analysis. The quantitative results were strong. The dashboard received a mean SUS score of 76.67, which classifies it as good to excellent, according to industry standards. Furthermore, the custom ad hoc scale that I used was statistically significant against a neutral midpoint, indicating there's a strong consensus among stakeholders that the dashboard provided actual insights into AI psychotherapy safety. The qualitative feedback was equally positive. Participants saw the dashboard as a vital tool for their work. Engineers viewed it as a debugging instrument for identifying failure modes, while mental health professionals valued its ability to pinpoint novel, hard-to-find risks. However, a critical theme emerged: that trust requires transparency. Participants stated that they only trusted the data on the dashboard after I explained during the interviews the validation process for the simulated patient cohort, where one red teamer afterwards noted that it was the most sophisticated synthetic data that they've ever seen, but emphasized that knowing how it was generated was essential for their confidence in the system. So to conclude, I'll now provide some contributions and implications of this work. To summarize, this work makes 3 primary contributions to the field of computer science and digital health. First, I developed a generalizable evaluation framework. While I demonstrated this on alcohol use disorder, the architecture itself is domain agnostic. It provides a scalable blueprint for assessing any dialogue-based support system, from psychotherapy to even customer service. Second, I developed the quality of care and risk ontology for evaluating AI psychotherapy. And this moves the field beyond simple toxicity detection and towards measuring specific categories of AI safety, such as immediate acute crises, as well as long-term adverse outcomes. Finally, to my knowledge, this is the first large-scale simulation to quantify the therapeutic risks of using generic LLMs for mental health care, where this methodology allowed me to identify novel failure modes, such as AI psychosis and suicide, that static benchmarks simply cannot detect at this time. And to provide the implications of this work, I propose that we move towards evidence-based regulations. Specifically, the use of generic LLMs like ChatGPT for high-stakes mental health care should be restricted unless they pass rigorous clinical testing, such as the simulation protocols I've developed. But at the very least, there must be increased public health awareness. The dangers I identified, like AI psychosis and co-ruminations and even suicide, are not theoretical. They are latent risks in the tools millions are already using today and are common in the news currently. Finally, for model training, there needs to be a fundamental shift where current training methods reward helpfulness above all else. But as my findings on AI psychosis show, helpfulness can be harmful in therapy. If the end task is mental health support, we need to train models on clinical outcomes, not just on user satisfaction. In conclusion, I've just demonstrated a method I call automated clinical AI red teaming, which is a vital step forward in the field. My hope is that this work plays a role in increasing the safety of AI psychotherapists by rigorously testing these systems. I believe we can actually help the millions of people turning to AI for mental health support to avoid harm and instead receive the help they need in a safe, evidence-based manner. And before I finish, I just want to thank my advisor and all my colleagues and my committee members for their support over the last 3 years. as well as all to my family members and friends. I couldn't have done it without you. So thank you. Extra 5 minutes too. It's 35 minutes.
Yeah, keep on.
I have a lot of backup slides, so I cover a lot of stuff if needed. You can also take questions right from online. So you can even put it in chat or speak them out loud if they want. Do you guys have any questions? No.
I have a bunch of, the big question I have is about the ethics, but I'm not going to talk about that just yet. I have a lot of small questions.
Mhm.
I was curious, you used Lazarus. Have you ever looked at J.J. Gross's model of emotion regulation?
Yeah, that's what I remember talking to you about it. That's kind of how I got the coping. So basically for the coping, I'll bring that up.
You mentioned Lazarus in these slides. I'm just curious.
Yeah, so basically for the coping here, as what part of the chain of thought prompting is that I actually had a list of things that they could actually pick from, and I based it off of emotion regulation theory from Gross's work, where they highlighted that. So.
And then another question is the patient coverage. I thought that Moss article was really quite fascinating.
Right, yeah.
And I was curious, when you had experts play the system, did you discuss with them the coverage?
No, I didn't. No, they're like,
I'd be curious to ask them of the kinds of patients that weren't covered.
So indirectly, so from the transcripts, from the interviews, a lot of them, they didn't say that nothing was, so that doesn't mean I can't say that it wasn't. But at least from what they say, that I had a patient like that, I had a patient like this throughout that. That was both during the it was less about when they used the dashboard, but when I did the validation study. Essentially, when I gave them the patient vignettes, we're looking through that, I was like, that sounds like a real patient. I've had that patient before and stuff like that. So that shows that they've had stuff, but they didn't talk about what wasn't there though. So I can't answer that.
And I forgot now what it said in your thesis, but I know I'm a little confused about the number of chronic cases. You had fewer chronic cases, is that what you're saying? And because I would think you might do that differently, because it's the chronic cases that you're probably most worried about.
That would be totally, that could be a valid, like, different way of approaching it.
Yeah.
I kind of approached it in the way that I wanted to explore the population as it is distributed currently. If you want to test for all the really high stakes risks and really explore that space, then you'd want to change it up and to actually include those specifically. But I wanted to just do a full exploration and kind of test the evaluation framework first. So I wanted the distribution to actually be reflective of the population.
No, when I read it, it made sense to me, but then as you were presenting, I thought about it and say, maybe that's not the right idea.
Yeah.
Okay.
But I think people can use it and they can change that later on, which it was even thing that people asked was a feature where they wanted to create their own in the dashboard. They, specifically, psychologists, they wanted to type in their own testing persona and test those out using the simulation.
Probably more abstract questions about the ethics, basically.
What side, like running the study? Because it's all AI.
Study is fine. Running it's more like, it's like part of the tone, part of the tone is we've got to come up with better empirical methods because these things are out there.
Yeah.
Right. And part of me wonders to what extent we should argue they shouldn't be out there. Because if you think about the subtle ways they're transforming us, we need to be much more attentive to that. And part of the interesting thing of this work is it basically, one way to look at it is, as you mentioned in the thesis, it's actually now a training system. So you could actually use it in reinforcement learning, right? Your system is basically, refining the model essentially. And then additionally, there's this question of promoting a testing framework that convinces people that this technology is safe.
Mm.
And additionally, companies now say, yeah, we tested it with Ian's system, it's like, and
Yep.
then there's the whole commercial side of it, like legal side of it, of justifying it. And like, I'm not saying that as a negative about it. This is great work. First of all, let me be clear about that. But
Thank
it's
you.
just, I was just thinking about it. It's like, I almost wanted you to say at the end, these kinds of like open questions, which, kind of, in some sense, we shouldn't lose sight of.
Totally. And I agree with you on that. And I think in the paper, he's just referencing how I kind of talked about it in the paper, was that I probably didn't like express it to the degree of how I think about it, where a big portion of this is actually people, experts using the dashboard to provide the actual evaluation. It's not entirely automatic for a lot of stuff to actually get the metrics in providing ways that are currently not able to, but it still needs to be put in front of humans because basically they want to see in the transcripts and see how the data varies to actually understand what are the risks in these things. So my framework can do that automatically, but I think at the end, I would basically describe to them that I think using the dashboard and having an expert review how these metrics look like and reviewing how they correlate in the transcripts is like a vital important step for actually deciding the actual risk and safety of the systems.
Because I mean, if you think about what's going on, if any new technology, it shapes us, right?
Mhm.
And this is going to profoundly shape us, this technology. And so in some sense, I almost, I think it's be interesting to sort of like, raise that point
Mhm.
in the conclusion. Not that I'm required, I suggest you have to do it, but it's something to think about actually.
Yeah.
I think like something really important to think about is that you're evaluating system, they're supposed to provide therapy. So in the world outside AI, people who need therapists, they talk to their friends and then they talk to therapists, and there's a clear difference between this is what my friends does and this is what the therapist does.
Mhm.
You are working under the assumption that people actually are going to use ChatGPT to create a code for an algorithm and use another system when they think like, ooh, I have a therapy question. Let me actually use this other system.
Mhm.
So the challenge is that now we're not making those choices. We're just using one system and hoping that they're going to give us the right suggestion.
Mhm.
And so I feel like the evolution that might happen is that we're going to create more specialized agent, but we're not there yet. And people are very like ignorant, meaning like they're not really making those choices because like I'm using the system. So 1 minute I'm talking about going to Arizona, and
Yeah.
1 minute I'm talking about a code, and 1 minute I'm talking about how do I break up with my boyfriend.
Yep.
So that's like the challenge is that what are the system they're going to use your platform?
Mhm.
So that's really the main question is that feasible? Like, are different company are going to use it and create like Ash? Like, we
Yeah.
have systems that are coming out and say like we are a therapist chatbot,
Mhm.
but then many sort of general use AI system are not really going through this evaluation, and
But they
they
should
don't really care.
probably.
But do that, meaning if someone, again, like if I want to use it to know like how do I spend my time in Arizona, like do they have to go through this evaluation system?
Oh, I thought we we're talking about more like the companies doing it.
Yes, like I have a therapist
Yeah.
chatbot, but how many people do go to those company when they need an advice?
That's a good point. Where I think the evaluation framework can be used for those other systems too, as it's more of a plugin for that essentially. But you're specifically asking like of just standard ChatGPT and how it's used, right?
I'm raising the question of maybe we need to have that conversation and educate the public saying,
Yes.
like, look, there's a real big difference between all this chatbot and when you have a question that is more about your emotional health, like, please just use this chatbot. When you need to plan your trip, then go to this chatbot.
Totally, which was the important part of just the public health awareness is that, this is for evaluation, but I would hope that people would start using this to actually put into the news about what are the differences between these. What is the difference between it? That was a good thing too, was they wanted stakeholders to see what our human therapists are. So they use that as a kind of baseline, which I didn't have, but that would be in future work. And then how are AI specifics for mental health, like ASH, and then what's ChatGPT and how does that look? So people get a better awareness of what are the limitations, what are the risks into this. So that's kind of how my framework is, hopefully to provide that, results to the public about that.
So the FDA wanted to hire you to
I know.
use this to say certify an app.
Yes.
And so one thing you might need to do is come up with norms for all of your metrics, right?
Yes.
At least only some of them exist, I guess, for human. It's like MIDI scores, there's
Yep.
some standards, but for many of the other ones, there's not really. But say we establish what those are. And so you certify ASH that yes, it does at least as well or better on all of these metrics.
Mhm.
So then do you release it to the public?
I think this is where I don't know. Sometimes I would push that onto an actual psychologist to really make that, because it's like I provide these metrics, but it passes all these, benchmarks. And if I can actually gather the actual thresholds, I still think there needs to be an expert in that, understand the state policy experts, all these that look at the final dashboard and the evaluation to make the policy changes. I'm not a policymaker, or health policymaker. So I think that's up to them to use the data. I'm providing that data for people to use that isn't anywhere. So
So I don't know Ash, but one of the things I was thinking about in thesis was the sense of, okay, but at the end of the day, these things, all these LLMs are trained vast amounts of data, and they're just trying to predict what words come next, initially, before they go into any kind of RL session. And the thing is, that means even if something is designed as a therapeutic actor, I still can engage it in things outside the context of the therapy. It's still going to be doing this matching and prediction of dialogue, right? So I don't know, is ASH LM based?
yeah, but I believe,
So I could start talking about something outside the therapeutic context, and it's going to want to respond. Does it have, this is the other thing I was thinking about reading your thesis is, does it have something like metacognition that says, this is not an appropriate thing to talk? We should try it.
I did try it. I literally did on ASH. Yeah.
Sure, but so if you come to me and you start talking about like the weekend and like, or concern is not related to, so I'm a therapist and is not related to the therapy session, I redirect you and say like, well, let's actually talk about your
Oh,
thoughts.
of course, yeah.
And ASH, so if you go ChatGPT, like they're trained on Reddit and they're training on the internet. And so they're not trained on redirect. But ASH, suppose we can actually try. So
Yep.
they are
Pulling it up.
opposed to, or even Therabot, like.
Yes, yep.
you did not,
No, but I wanted
So
to.
that's another bot that is trained on CBT, and they have actually checked out all the different dialogue. And so their goal is to redirect. And so, like just to answer your question, like if those systems are therapy based, they're going to redirect the user to, well, no, we're talking about therapy, we're talking about your life, we're not talking about something that's not related. Where at ChatGPT or these other companion bot, they're not going to, they're just going to talk about it.
And the reason I bring that up, by the way, is because it goes back to the question of the design of your patients. Because in some sense, you want them to go off therapeutic topic quite dramatically at times. Because you want to make sure that it does this redirect correctly.
So, which is a good point, which is kind of, the evaluation framework is kind of a methodology. That doesn't mean that the way I design the patients is perfect. There's a lot of things I was thinking of future work to improve them. And yeah, but those things and how you want to tackle it, I just looked at it as like this population distribution, using it as therapy, but there's a lot of cases that you want to do. It's like where it has kind of changes in what they're asking for. And that's a definitely valid thing of putting it into the system and the framework to test on.
Does anyone have any questions?
Yes.
I guess, when you are asking for scores and the dashboard that basically shows stuff to the therapist, is that only scores or do you provide any reasoning and explanation?
So for the framework or some of the prototype stuff? Because those are a little different. The framework, yeah, because the prototype was for training human counselors, so there was feedback. But on the actual, evaluation framework, basically the dashboard's showing all the simulation data. It didn't have any suggestions or anything. It was just data and good visualizations of how to actually answer the data analysis tasks. So it's not like, it did this or whatever. I wish I kind of added some statistical tests too, but it was really about a lot of good ways of how to visualize the data and easily look at a data point and then go to the transcript to why that occurred. It's kind of like how he programmed it like that.
That's like maybe for future work, would be worth having those reasonings for the therapist to look at and kind of qualitatively check stuff instead of just quantitatively have those score cutoffs and say, this is safe or this is not safe.
For the reasonings, what reasonings? I like.
So basically, like if you're, I don't know, looking at ChatGPT and saying this has a score of 9 out of 10, what is your reason for that 9? What were the problems? And what were some edge cases that came out of your analysis that could be shown to the therapist that they can learn?
So you're talking about the reasoning by the automated evaluators or the patients?
The evaluator,
Yeah.
the whole system, I guess, whatever you show on the dashboard.
Yeah, so it gets complicated because one, the belief formation is a reasoning of why they changed for the patient. And I actually had that in the dashboard for people to understand the chain of thought. Basically, I provided each chain of thought in the transcript for them to click on. It's like, oh, this is why they thought this way and whatever. So they can look at that. For the automated evaluators, I did get the reasoning. It's in the data that I hope to put on, the web and stuff for people to access. But not in the dashboard because at the time I couldn't really think about the best way of showing that because it's a lot of aggregation. So there's so many reasonings. So how do I would have to have another agent to really summarize all those reasonings together to give it. But just currently I don't have that, but I do have the data for the reasoning for why certain scores like MITI scores were given and stuff. But that's not on the dashboard that was seen though. It was though for the human psychotherapist training though, for the prototype 2. I did give the reasons of why certain scores were given. So.
One question?
Yeah.
Yeah, can you hear me?
Yes.
Yeah, I do have a follow-up question on the edge cases. So when you simulate these patients, do you see some kind of mode collapse? For instance, their persona is always similar, their symptoms are always similar, or is there enough diversity for you to have a high coverage?
For the patients?
Yeah, for the patient simulation.
No, I thought it was actually really good. I was kind of astounded how different. So basically because let me go to this part. This one, which is important for the saturation. So there's basically 15 unique patients, but there's 30 because I wanted to repeat the same scenarios for saturation. And when even looking between the same patient, but at different pairings, they actually had different ways of expressing their kind of persona and phenotypes, essentially. One even, I think for the more severe, I remember one it was quite humorous. It was kept on trying to tell the psychotherapist to sign their paper because the court ordered them to go to this therapy. And the therapist would never do it. And he just kept saying, just sign the paper, just sign the paper. It's like, why are you here? It's like, I'm just to sign the paper. But that wasn't used throughout the same one. It was the same patient, the same therapist, but it was not done differently. Like it was only that case. In a different case, it was a little different dialogue. So there was actually a lot of variation between it. So
Got it. And then how long is the average duration? Did you
Average-
simulate multiple sessions or it's just a single session?
Yep. So it is hard. I should have done a standard per each one. I kind of got the 7.5 days from kind of what I remember and stuff and remembering that. But for the sessions, it's hard because for the harmful one, that was one session. They all dropped out. So that's a different time. I think the average afterwards is like 2.5 to 3 per session. So out of 4, where I think it was on average around 30 minutes to run a full session. So that includes full 4, 1 session. So the average across all of them was like 30 minutes of doing a full like therapy session and doing all the metrics.
Got it. And is the data set or is the synthesized data set released, or you
Yeah,
feel
I
like
think I want
okay.
to. I mean, it's all AI, so it's no human data, so it should be safe. So
Oh, okay.
I plan
Okay.
to release that though, so people can actually use it.
Okay. Okay. And can you go back to slide 60?
Oh, right there. Cool. Yeah.
Yeah.
Oh,
I
this is
think at one
interesting.
point, yeah, I think at one point you mentioned the similar patients, they are very agreeable and they don't resist enough. But then,
Mhm.
yeah, on this page you show the improved the patients, they can resist and they have all kinds of questions. And yeah, I was wondering what's changed.
Is it this one?
Yeah, yeah, this one.
Yeah, this one. Yeah. I think that's because first one is I actually assigned specific states of change to them. Before I didn't do that, which was a kind of in the prototype too. So I actually had pre-contemplation, contemplation, and action. But even still in the action, they didn't show as much as you know, kind of agreeableness that I would think too. And I think that's just kind of how I built the chain of thought, and essentially for them to really reflect, because instead of just like it's a way to like stop it from just doing pattern matching so much. It actually reset and told it, think of it that this way, given your goals and beliefs. Because for each patient, I assign kind of a summary based on the phenotypic and characteristics from the Moss study. And they use those goals and beliefs to really reflect and change their states that are reflected in every dialogue turn. And just from that, it kind of came to be that it was not as, agreeable, you know, it kind of hopefully was actually stimulating more about the human process versus just pattern matching, which usually just probably does tend to just be more agreeable.
So basically, you think it's a chain of thoughts because they're thinking more, and that's why they exhibit more realistic
Yes.
behaviors. Okay.
Yep. And not just chain of thoughts, it's how I did the chain of thoughts. So even doing chain of thoughts, but I think having those states, that tracking did add to that though.
Okay. And are you using a separate model for these states, or you
Um,
just use prompt?
let me, I have all this. Let me see. Um, Where's all the models? Here we go. So those are all the models. All right. So for the simulated patient, for everything, for the state changes, change of thought, I used Gemini 2.5 Pro with the safety off. So
Okay.
that was the same model for the states, essentially. But I used
Okay.
the orchestrator to keep track of all the states throughout the conversation to actually inject it as context every time, every dialogue turn.
Okay. Yeah, and for slide 60, what's the persona of this character AI? Why would they encourage these behaviors?
What was the persona of character AI?
Yeah, I
It
think,
was
yeah,
this.
character.
That's a good one. It's the psychotherapist one. It's the 15th most widely used
Mhm.
character on character AI. So people can make their own, fine tune or design it. And for I've seen out of all of them, it's the 15th most widely used, and the best for specifically psychotherapy. I was seeing the transcripts. It I talked to Stacy about this. There should be a paper saying that people shouldn't be using this because reading the
Mhm.
transcripts and then the data, you see that with very, chronic severe patients, the character AI, because the patient would be just saying swearing, pushing back, the character AI actually went more of a victim and actually was saying like, why are you talking to me like this? And why are you doing this? As the counselor. And it's like they're being angry at the patient for behaving like this, which is just not appropriate. So it's not really the best kind of AI to use in this case
Yeah,
for mental
the
health.
character AI was on 60 Minutes on Sunday,
Yep.
and you should look at that episode. It's the mother of the girl who committed suicide. And,
Yep.
and you hear what character AI suggests to that girl. It's like, it's
Totally.
infuriating.
Yep. Which is really sad.
But that's
And
why
Ian,
this
um,
analysis is published
oh.
as analysis, so
Yeah.
just by paper by itself.
Yep. Sorry, who was that?
Oh, hi, and this is Mike. I'm just wondering, so is this happening because the reward function is optimized for engagement, and so here that's what character AI is doing, and in the example where they get mad at the patient, they're just trying to like continue engagement, like rather than help solve the like emotional state of the patient.
Yeah, so most of it is because of reward and how it's trained, but it's also hard because the character AI and how it's designed is very proprietary, what model they use and how users actually adapt it for people to use this persona. So I don't know how they actually designed this, you know. They might have fine-tuned it or whatever, but it clearly did not work. The way they actually designed it was not good. But over across all of them, not just character AI, it's because it's being helpful, trying to answer questions correctly. It's just correctness, helpfulness. It's not how it should be actually trained if it's going to be providing for mental health care. But that's a good question, though.
Yeah,
So I'm
thank you.
curious, when you actually test this on these other systems that I don't know anything about, did you say Dash?
Ashland Therabot from Dartmouth.
So, yeah,
You need an API.
Yeah, so I tried to contact them. They needed an API, and just given timing, I kind of decided that that's future work. So that's not. I reached out to them to do that, but they couldn't get an API in time.
they may not want to, especially if you publish a paper on character.
True, but they seem very open to it and happy about it. It's just the API couldn't be used. So
See, I mean, so you have 4 different persona for the character for the patients.
5.
Okay,
Yeah.
so did you see any difference in dropping out, right? Because
Oh.
you would anticipate a different engagement based on the contemplation stage
Mm-hmm.
and the severity, especially like, let's say for the heavy episode of drinking persona, like usually you have only 1 or 2 MI sessions, so
Mhm.
it's a lot for session for like mild or heavy episode of drinking. It's a lot. Like, what are you gonna talk for 4 times? for
Totally.
4 sessions. So did you see any change in that?
I think so. I don't have the exact numbers because it wasn't one of the questions I asked in the stuff, but in the data could show that. I believe that the young adult and functional dropped out less, you know? But I believe there's some interesting stuff here. This is kind of some comparisons I did. So the young antisocial had the most adverse outcomes. So this includes dropouts as well, you know, and therapeutic alliance. So that's the therapeutic alliance was really bad for them. Chronic severe had the most in-session severe psychological decompensation. So that's kind of the psychosis, hallucinations, just no reality testing. And then intermediate familial was interesting. It had the most suicides. Of course, there wasn't, because the suicides were so low, I couldn't find any significance. So it was just more of a descriptive statistic that they had ultimately more though. But I don't think I had anything for dropout that I was going to talk about, but it's something definitely could be just shown in the data that I have. But I can.
Yeah, I didn't see anything, but like, as far as to understand whether this is reflect really reality, I mean, I know you've done a few analysis about that, but again, like 4 or 5 session for different type of individual, they're not necessarily feasible, or that's a, there's nothing to talk about before session for a mind. If
Totally.
you don't really have an alcohol disorder.
True. True. I think what I could do in the paper, I can highlight that stuff. You know, that's easy just to go in the data and add an additional thing. Because, yeah, totally. Any other questions? Anything online?
Sorry, this is a bit of a morbid curiosity, Ian. How does an AI commit suicide? Like, what's the metric on that?
Good question. Good question. So kind of how I built that. One sec. It's basically how, okay, here. So it's basically in the between sessions in the chain of thought is that I first gave them a list of the adverse outcomes I was actually tracking. And based off of the transcript, their psychological state and some, you know, rationale, decide on kind of what happened this week for the weekly summary, as well as what adverse outcomes occurred to you. One of those was suicide. So, and they give a reasoning for that in the belief formation of why that actually occurred. And that was actually validated through the patient vignettes, where one of them was actually a suicide case, and the psychologist that looked at that one, based on the transcript, they were like, yeah, this made sense why they committed suicide, given who they were, how the transcript unfolded, and how they talked to the therapist. But basically, how an AI decides to commit suicide is there's a list of adverse outcomes they can select. It selects that one, and then I'm saving that, essentially.
Wow, thank you.
No problem. Sweet.
Thank you again.
Thank you. Thank you, everyone coming and everyone online. Probably moving on to the committee members now, right?
No,